was, if anything, the first data steward of the EPD. He was a critical piece in this database puzzle. Rachid worked closely with Eric, setting up the skeleton of the European pollen database and really fostering open science. So Rachid will be presenting now Eric and the early days of the European pollen database. So Rachid, whenever you want, the floor is yours.
Okay. Just want to share the screen.
Yeah.
Can you see my screen? Or yes.
It's coming, yes.
Well, I don't know.
I
How
see a
does it look
white,
like?
it looks to me like a white screen. I don't know for the others.
Okay, let me try it again.
Yeah, no worries. We are doing fine on time. John was really sticking to the time. Okay, now I see Eric.
Is it
But
okay?
yeah, I see myself too.
But okay, okay. Thank you, Graciela. Can you hear me?
Yes, we can. Yes.
Okay, thank you, Graciela, for inviting me to this memorandum, and it's yeah. I will say some words about Eric first before talking about his involvement in EPD and so on. I met Eric in 1991 when I started working for the European Pound database with Jacques-Louis de Beaulieu and Joël Guillot. And in fact, Eric came a couple of times to Arles, which was the home of the European Pound database. Uh, so we had the opportunity to meet, and he met my wife and kids. And when I visited him at the Illinois State Museum, I met his wife and daughter also. And so Eric was for me also more than a colleague. He was a friend. So it's really a bit strange and sad to think that he's no longer among us. Um, I have read what George and Richard and other colleagues have written on Eric's life and contribution, and I totally subscribe. It's exactly what I think of Eric. But Eric had a direct impact on our community. This is obvious, and we all agree on that. But he had also an indirect impact, and this is something I will try to show through 2 or 3 slides. And it's really interesting because his involvement helped so many young scientists um, to make their research so that it became almost how to say obvious that databases are a kind of a central tool for their research. So Eric's contribution in this regard was indirect impact was is obvious. Um, I think that we everyone knows this massive work published by John and Brian in 1983, before any database existed or and computers were at the Stone Age. So the isochron maps in this atlas required a huge amount of fossil pond data. I don't know how they managed to do this work and how much time it took them to do it. But um, at that time, if you open this atlas, um, it's it was made by 2 scientists, but now we have reached a point where we need this kind of data sets to reconstruct past distributions, migration rates, paths, refuge, and so on, to improve our models. So um, when I look at this work and what we can do today with databases, it's huge. Today, it doesn't take years or months to make maps like those that John and Brian made in 1983, but it takes a few minutes. It's a simple query, and we can extract huge data sets from a global databases and so on. So um, it's much easier today to work on databases, and we don't realize how uh, these global databases can make our research more accurate and useful for modelers and paleo community in general. Um, yes, in North America, I think this is the first initiative I know of using a global fossil data set for reconstructing past vegetation, lake levels, past climate, ice sheets, and so on. And cherry on the cake, it was used to validate model simulations. And this was published in Science in 1988, before the North American Pond database, any database existed, or Neotoma, or any database. So this is also a huge work made by the COMAP group. Many members of the COMAP group have then contributed to building and to setting up the North American Pond database, and some of them like Brian Huntley, I think, have then contributed to setting up the twin sister, the European Pond database. I think we would all agree to say that at that time in 1988 there was a huge gap between North America and Europe in terms of data archival, data sharing, spatial synthesis, and these large scale climate and vegetation reconstructions. Um, and so this gap between North America and Europe has been, how to say, improved when the European Pond database started, and we started to collect data in Europe and build a database at the scale of Europe. So in 1990, the European Pond database was born, and Arles, this little town in southern France, was its home. EPD was hosted by the University of Marseille, and it was coordinated by Jacques-Louis de Beaulieu and Joël Guillot at that time. It was funded by a European project which lasted for 5 years, and it helped setting up the structure of the European Pond database and to start the archival of the first data from Europeans. And so this is the place where we used to have our EPD meetings and computer trainings. This is a kind of a famous place in, I would say, in the world, because it was painted by Van Gogh a century ago. Initially, it was a hospital where Van Gogh stayed for maybe a couple of months before he cut his ear, and he had the time to paint it at that time. And so the place was renovated, and on the right hand side you can see this is a picture today. It was renovated exactly as Van Gogh painted it. And so now it's a public library with some offices for the city, and these tiny windows that you can see are rooms and offices where we used to organize the computer trainings with Eric. He came there, and I think we organized, I don't know, maybe 2 or 3 training courses for Tilia and how to use Paradox, the software that we were using for handling the European Pound database. And Eric enjoyed a lot this place. And I I think he took pictures of this place, and I couldn't find any picture of us in this place, unfortunately, but he used to love it very much. So beside the official meetings, and there was also an amphitheater in this place where we had a couple of meetings related to the European Pound database. And so beside the EPD meetings where the advisory board and scientific committee met, we had, when I say we, it was Eric, John Keltner, and me, and sometimes Steve Juggins, if I remember well, talking about the nitty gritty things like uh, how many tables, which fields, how do we relate these fields together, how do we index them, where are the keys, these things. And of course, if you look at the EPD structure today, which looks like uh, something strange. There are at that time, there were more than 40 or 45 tables with tens, maybe more than 100 fields. And our work was to set them in a way that can archive the data and metadata of each fossil site in the database. It is a relational database, which means that all tables are related with indexes and keys. There are no redundancy, and it is a normalized database. And all these normalization process was done with Eric and John Keltner. Before we reached a stable structure, it took us some time. It wasn't that easy. Moreover, we had discussions with the European colleagues, which had different opinions about what to archive, where to archive it, and so on. So the stable structure of the North American Pound database and the European Pound database uh, were not very stable over the first years, I would say. So this is something that I have been doing with Eric and John, and this is why I visited Eric at the Illinois State Museum for this kind of discussions to set up a normalized structure that can ease the data archival, but at the same time the retrieval of data, because as you can imagine it, how to find data from 40 tables if it's not normalized, it's very difficult. So this was also a task for us to be able to have a database with a structure that can be queried easily, and data can be retrieved in an easy way. And the training courses I was talking about were also not only on Tilia, but also on the European Pound database, and how to extract data from the European database and how to use it. So we had a couple of training courses at that Van Gogh garden that I showed you a couple of minutes ago. Um, the In the early days of EPD, computers were not so friendly. It was a DOS version, and all software that we were using were there were firstly there were few software, and most of the software that we were using were not very friendly. So we had to everything has to be programmed as its own language. So any form or any table had to be written using a script, a Paradox was a software that we used, which was a relational database with its own language. So with Eric and John, we wanted to ease our life for, of course, entering a massive data into the database, and also allow colleagues to extract it as easily as possible. And this is where Eric had this brilliant idea of a software that would help colleagues to um, enter the data, play with it, as Thomas said, there with some statistical tools. They can plot their pound diagrams, but at the same time, and this is the most important part for the European pound database, he implemented forms in I will come back to this. Um, uh, and these forms, as you can see on this screen, there is a menu. It's the L menu on the left hand side here. I don't know if you can see my mouse, where you can enter the metadata into forms. And this is a brilliant idea because not only colleagues can enter their pound data into a standardized spreadsheet, which is connected to the database because the pollen identification archived in the European Pound database was also used as a dictionary in Tilia. So Tilia was directly, to some extent, connected to the plant library that is archived in the European Pound database. And at the same time, a user can fill in forms with metadata related to the sites for which he or she entered the pollen counts. And this is where the idea was brilliant, is it's a win-win process. The user can have his data, pollen diagram, and zonation, and so on. But once he or she has entered the data, the Tilia file can be sent to the European Pound database, and just few buttons, and then we have the data, all the data split into tiny pieces and spread all throughout the tables that are in the European Pound database. This wasn't easy in the beginning, and we had to write lots of scripts to enter data from papers and so on into the European Pound database. But with Tilia, we had a tool, a super tool that can ease our collaboration in Europe, getting the data and enter it into the European Pound database without any problems or issues. Of course, there are lots of, I would say, jokes or about Tilia, because when Eric started to write Tilia, it was I don't know if the word buggy is good, but there were bugs, and the problem is that with those versions at that time there was no backup on the hard disk, and so every time anyone enters data into the software, he or she has to save the data immediately. Otherwise, if it crashes, and Tilia crashed from time to time, the data was lost. So we had some complaints from colleagues about the time they wasted, and they said they lost and so on. But uh, I would say 99% of the time, Tilia was super fine, and we made a huge progress with Tilia in terms of data archiving and collecting data from colleagues. And here I have to say that this was very, at least for me, it was very impressive, because at that time there was this American initiative about the open access software, Linux, and the GNU license, and copyleft software, and so on. And Eric was how to say, avant-gardist. He had his software free of charge and totally available for anyone. And I think we have discussed the source code of Tilia, and he was ready to give the source code. So uh, he was ahead of his time. He was putting all his time into this software and giving it to the community without asking for anything in exchange. This wasn't the mentality at that time. I remember when Windows came up in 1990 or something like that. We had to buy all software, and everything was we had to pay for everything. And Eric was just released all his software free of charge and for everyone, which was impressive, I must confess. Now, just a few words about the indirect impact of Eric's contribution to our community. And the indirect impact is that when at least for the European Pond database in 1994, between 94 and 96, when we started to have a decent data set archived in the database, in the European Pond database. That's where we were asked by colleagues, modelers from vegetation modeling and climate modeling to quantify and to represent vegetation in such a way that we can validate their models. And this is the biome model published by Colin Prentice in 1992, I think. And at that time, he validated his model with all sorts biomes. But when in 94, EPD was officially released and the data, and we were allowed to use the unrestricted part of the data, Joël Guillot made this reconstruction to validate the biomodel in the frame of the Biome 16 project. It's a European project also. At that time also, Colin Prentice has contributed with his method for making biomes, the biomization method, which is a method to organize or to reconstruct to construct biomes based on plant functional types, which are based on pollen data and plant climate requirements. So this was a major step in the sense that we had a database, and with few click, we were able to extract um, pollen data, convert them into plant functional types, biomes, and compare the data to a model. It didn't take ages to do this. This is, at least to me, a major step in terms of data model comparisons. And after this, of course, there were other initiatives in Africa, in Eurasia, and Latin America, and so on, with the other databases, which were also built with the same structure and are also twin sisters or twin brothers to the North American pollen database. There were also, and this is the last example I will talk about, requests, I would say, from the climate community. There was a project, the Paleo Paleoclimate Model Intercomparison Project, PMI project, within which more than 20 models were involved all throughout the globe, from Japan to North America and so on, and they were producing um, uh, climate simulations, and they needed also some climate reconstructions to validate their models. And there again, we were able to contribute some information to validate these models. Um, these, yeah, maybe this is my, I would say, my very last example of how mm, databases may contribute. Everyone knows this example of the input of pollen data in Europe in the in phylogeography, and this is the case of oak in Europe. This was published in 2002, and this is to show that without databases like the European Palm database and the North American Palm database and so on, these kind of works would have never been possible. And this is where, to me, we should not forget colleagues who were at the very beginning of an initiative like North American Palm database and the European Palm database, because this slide that you see here um, contains, I don't know how many fossil records and data sets and so on, which that we used in a very simple, well, in a more or less very simple way, because colleagues like Eric made it possible. Without colleagues like Eric and others, of course, I should not forget John Keltner, this work would not have been possible. So, if I may say a last word about Eric, I think I would say that even if there is a wealth of fantastic data in Europe, and there is, of course, a wealth of fantastic data in Europe, but it's just like in a concert. We may have tens of fantastic instruments and fantastic players, but without a maestro, we can't make a concert. And to me, I think that Eric was a maestro for our paleo community. And so I remember Eric as a right man and devoted, kind man, and he was really the right man at the right place. This is at least my memory of him. Thank you very much for listening.
Thank you, Rachid. Wonderful presentation to covering every aspect of the origin of the European pollen database and how you and Eric were involved from the very beginning. I really liked also when you said that Tilia crashed every so often. And well, I think that